Okay, if you just watched our explanation, or my explanation on how infinite converging series, how to get that formula and where they occur, you just saw this last slide. Well, now we're going to go through examples on applying this, okay, and actually finding infinite series, all right, and find the sum of these infinite series. So I have 3 examples here of finding the sum of these infinite series, if they're possible. All right, we're going to try to figure them out. Now, recall that each one, in order to find an infinite series, there's 2 criteria. It has to be geometric, so it has to be exponential, all right? And also, whenever you have geometric, the ratio has to be less than 1, greater than 0. That is the only way we can do it. Okay, so each time we're going through here, we're going to identify, is it geometric, and do we have a ratio less than 1 or greater than 0? All right, so first one, example number 1. We can see that, yes, it is geometric, check, and it has a ratio which appears, a ratio which equals 2/3. That right there is going to be less than 1 and greater than 0, and so we can find this converging series. All right, so let's do this. We can use whatever formula we want. I don't know what people will do. A lot of times they'll just use this right here. However, if you don't like this formula, which is really simple, and it helps you remember, just remember it's geometric. And if you just remember to take, okay, we're finding when n goes to infinity, just plug all the values in. So we're going to use this simple formula. And if you're good with limits, this totally makes sense, and we can do this. All right, so I'm just going to use this one just to help so I'm not memorizing all these stupid different formulas. So when we have this, we're going to find our first term. So we plug in 1, all right, into here, and we should get 2 for our first term. So a sub 1, all right, when we plug this 1 into here, this is our first term right here. I guess it would be I in this case. All right, so when I approaches infinity. All right, but we plug in 1 in there, and we get 2. All right, so we get 2 for our first term. Then we're going to have, and this should be I as well. All right, we have 1 minus our ratio, which is 2/3. All right, I right there. All right, remember we obtain the limit as I, in this case, goes to infinity, because that's what my index is. And we have 1 minus 2/3. Going through here, we're going to simplify this now. As this goes to infinity, this is going to turn into 0, because it's going to become a smaller and smaller value. We have 1 minus 2/3, this part, which is going to be 1/3. And then all that's going to be multiplied by 2. And so you have is 3, when you simplify this, times 2, which equals 6. So this converges to the sum of 6. So if you add all these values together, it's all going to converge to 6. Pretty neat. All right, let's try another one. Okay. Over here, once again, we go here. We have n this time. So we'll take, see, this is geometric. It is, check, because it's exponential. Do I have a ratio which is less than 1 greater than 0? Well, my ratio right here is 5/7, which is definitely less than 1 greater than 0. So yes, it does have a converging value. So we're going to take the limit here. Now I can use n, because my index is n. We're going to approach infinity. I'm going to find my first term. My first term is going to be here, because we're going to use this equation again. Okay. So my first term, I'm going to plug in 0. So I have 5 times 5/7 to the negative first power. We're going to have 1 minus my ratio, which is 5/7 to the n, over 1 minus 5/7. We can simplify this. All right. 5/7 is reciprocal, so what we're going to have is going to equal 7. This right here, as n goes to infinity, this is once again going to be approaching 0. So we have 1 minus 0, which is, all right, 1. 1 minus 5/7 is going to give us 2/7. 2/7. And so we simplify this, and we have 7, this reciprocal, times 7/2, and we have 49/2 is our converging sum. So that, if we took all the values, just so you know what this equals, if we took all the values together and we took them to infinity, the sum, all right, the infinite sum would equal 49/2. What is 49/2? Okay, that's what we found. That's pretty cool. That's pretty neat. That's some higher level mathematics there for you. Okay, well, let's go to the last one. All right, and what we have here is, once again, all right, go through our little checklist. We want to find the infinite series. So can we do this? So is it geometric? Is it exponential? Yes, check. All right, is my ratio less than 1 greater than 0? Because it only works for those. My ratio is, it appears to be 4. All right, 4. Well, is 4 less than, no, it's not. It actually is greater than 1. So can we do this? Actually, no, we can't do it. This one actually diverges. It diverges. Can't do it because we only have to fit these criteria. So this is yes. This one was no. This is sad face. All right, can't do it. All right, which actually make you happy because you don't have to go through some more work. All right, but that's what we got. All right. So 2 different problems of finding infinite series. You only can do it when you have geometric and a ratio which is less than 1 greater than 0. Hope this helps you out. This is applied in Calculus 2 when you're talking about converging series and whatnot, especially with geometrics. These are simple geometric series that go to infinity. All right. So good luck and God bless with the rest of your work.